Hello guys, today we're going to integrate this integral. Today we're going to integrate this integral, which is just the integral of square root of x plus 1 minus square root of x minus 1 over square root of x plus 1 plus square root of x minus 1 dx from 1 to 2. So we can let this integral, we can let a is equals to square root of x plus 1, b equals to square root of x minus 1. Then how we're going to solve this is to just replace everything with these variables. I'm going to simplify this using algebra first and move on to calculus later. So what I can do now is multiply this with x a minus b. I'm going to multiply it with the conjugate, which is just, these are very popular formulas. You guys have to know them if you guys want to continue on even further. And then when we have this, we can resubstitute these back into this. So remember guys what this is? This is just a squared plus b squared minus 2ab over a squared minus b squared. Okay, so what is a squared? So a squared is x plus 1, right? And b squared is also x minus 1, like this. So then we can put it into as x plus 1 plus x minus 1 minus 2. What is this times this? Well, that's just the square root of both, right? We just have this x plus 1 x minus 1 like this over a squared, which is just x plus 1 minus b squared, which is just x minus 1, x plus 1 because we multiplied like so. This x with x, that's 2x. This thing cancels out, minus 2. And then what is this? This thing is just like this, right? So we have the square root of x squared minus 1 squared, or because 1 squared is 1, I'm just gonna write it as 1 like this, over this cancels out, right, leaving us with just 2 right here. And then this we can simplify even further to get this. So divide by 2, that's x. Divide by 2, that's just itself. So it's just minus square root of x squared minus 1, like this, dx, right, like this. So we just simplified this into this. So because we have this, we can separate it into two integrals, where we have the integration of 1 to 2 of x dx minus the integral of the square root of x squared minus 1 from 2 to 1 dx, like this. What is this? Well, it is very popular. That's just this rule, which is just xn plus 1 over n plus 1, like this, guys. But because this is a definite integral, we don't need to add the plus c. So this is just x squared over 2 evaluated from 2 to 1. What is that? That is just 2 squared minus over 2 minus 1 over 2. 4 over 2 minus 1 over 2, that's just 3 over 2. So this thing becomes 3 over 2. What about this one? The integral of 1 to x squared minus 1 dx. What does this one becomes? Using trig substitution, guys. So now we're trying to integrate the square root of x squared minus 1 dx. How do we do that, guys? So we have to use something called the trig substitution. Okay, I'm gonna set x equals to secant theta, right, like this, because this has the form of x squared minus a squared, the a being 1, like this, guys. And then we can take the differential of that. And what's the differential of secant? Well, that is just secant theta tangent theta d theta. Because we're taking the differential of that, we also can change everything back to that. So then this becomes the integral, I'm gonna put it right here, of secant theta. Also, don't forget over the square root, squared minus 1. Also, guys, don't forget, what is this? Well, if you guys know from this formula, this is just tangent squared, right? So this is just square root of tangent squared theta, which is just tangent. So then we have this integral converted into this, so we can continue on. So this is just tangent theta. Then now we put the dx as this, so now we can just replace secant theta, and then because it's tan, I'm gonna multiply with this, so it's just tangent squared theta, secant theta d theta, like this. Also, guys, from this formula right here, we can simplify it even further by changing the tangent squared x into with this formula right here. So this is just the integral of I'm gonna replace it there, so it's just secant theta times secant squared theta minus 1 d theta, like this. Also, guys, this all looks very confusing, but bear with me. Now I'm going to distribute it. So this is just the integral of secant cubed theta minus secant theta d theta, like this, guys. Now I'm going to separate these integrals because this is a minus sign, so this is just d theta minus integral of secant theta d theta, like this. So now we have two separate integrals. One of them is pretty easy to solve, the other one is quite hard. Okay, guys, so I have this line made up because I'm gonna integrate some serious stuff. So in here I'm gonna integrate secant theta d theta, which is just this formula right here, the natural log of the absolute value of secant theta plus tangent theta. I'm not gonna write the plus c because yeah, it's not really that necessary. And then for secant cubed theta d theta, so yeah, now this is just the integral of a half secant theta tan theta plus a half of natural log of tan theta sec theta tan theta tan theta. So the integral just becomes this. If you guys are wondering how I got that, it's just using integration by parts, but I'm not gonna cover up in this video because I'm gonna make the video too long. So then we can continue on minusing the integrals. So then I'm gonna erase everything. So guys, after I combine them, we have this. So it's just the half of the secant theta tan theta plus a half of natural log of secant theta plus tan theta minus the natural log of secant theta plus tan theta. Because we have natural logs here, we can just combine them. Okay, so let's just let this into be like a variable, and then this becomes a variable. So this is just a half minus 1. What do we have? We have negative a half of that, right? I'm gonna write it out here. I'm gonna write it down here now. Okay, now guys, we have this. So we minus this, we have this now. But guys, remember we have bounds for this. So so we don't really need the plus c in this case. I'm gonna delete it. Then we're gonna convert it back into x. Remember guys, so secant x is equals to x. The differential of x is equals to the secant theta tan theta d theta. Okay, so after we're replacing it back to x, we have this, and then this already integrated it. Don't forget we have this now, the bounds. So we're gonna have it from 2 all the way to 1. I'm gonna delete everything here. Okay guys, so we have this. Okay, so now we have this antiderivative. So first I'm going to evaluate it at x equals 2 because there's a top one. So 2 over 2 is 1, and then 2 squared, 4 minus 1 is square root of 3. I'm gonna write the square root of 3. 1 over 2 is half, and then this becomes 0. So we have ln 1, which is 0, so this thing cancels out. So yeah guys, the integral of this becomes this, right? So yeah guys, this is the answer to our integral of this one. I'm going to remove everything. Also, if we put it in a calculator, it results into 0.42642, and it keeps going on. So yeah guys, if you find this interesting, hit the like button and subscribe in this video to let me integrate more functions like this. Subscribe!